Hello and welcome. In today's video, we are going to be finding inverse functions, and we're going to be going through three examples, and the three examples are shown here on the screen. So without further ado, let's get it. Example number one, we have f of x is equal to 5x minus 3, and we want to find the inverse of that. So to begin, we're just going to rewrite this a little bit by changing this f of x to a y. So we're going to go put y is equal to 5x minus 3. And now what we do is we replace the y and the x. We just change their spots. So then it becomes x is equal to 5y minus 3. So all we did there was just change the variables, just change the locations of them. And now what we want to do is solve for this y right here. So the way we do that is we add 3 to both sides. And then you get x plus 3 is equal to 5y. And to get y by itself, you divide by 5. So now that means you get y is equal to x plus 3 over 5. Now, there's only one more step you have to do from here, and that's just rewriting it, in the way they want it. So this y is actually going to be f to the negative 1x, which denotes the inverse is equal to x plus 3 over 5. And that is going to be your final answer. Example number 2, we have f of x is equal to 8 over x plus 1. So we're going to begin the same way. We're just going to change the f of x and write down ay is equal to 8 over x plus 1. And from here, we change the y and the x locations. So when we do that, we get x is equal to 8 over y plus 1. And now what we want to do is isolate this y here. And the way we do that is we're going to multiply the entire equation by this bottom part here, the denominator there. So y plus 1. Okay? And when we do that, we will get x times y plus 1 is equal to 8. All right? And now we want to isolate the y, so we're going to divide by x, divide by x, and then that is going to give us y plus 1 is equal to 8 over x. And now we just have to subtract 1 to both sides, and we get y is equal to 8 over x minus 1. All right, and the last step here is to rewrite it in the proper form. So f to the negative 1 of x is equal to 8 over x minus 1. Now, the only thing that is here is that this x, we know that it can't be a 0 because it's going to become undefined. So what we usually do to denote that is we'll put a comma, and then we'll state that x cannot equal 0. And then that is going to be our final answer. Example number 3, we have f of x is equal to 5 minus 6x all over x. So we begin, like always, we're going to just rewrite this and switch the f of x to a y. So y is equal to 5 minus 6x all over x. And now we swap our x's with our y's. And we got to remember that every x gets switched with a y and every y gets switched with an x. So we get x is equal to 5 minus 6y divided by y. Like that. So all the y's have been swapped with the x's. And now we solve for y. So what I want to do first is eliminate this fraction. So I'm going to go ahead and multiply the entire equation by y. And when we do that, we get xy is equal to 5 minus 6y. And from here, I want to get all of my y terms to one side. So to do that, we're going to go ahead and add 6y to both sides. And what we get is xy plus 6y is equal to 5. And now I'm just going to go ahead and rewrite this up here to give us some more space. So we got xy plus 6y is equal to 5. And I want to get y by itself. So when we're looking at the left-hand side, you can see that there's a y in both of those terms. So I'm going to go ahead and factor that out. Okay, so if I take away the y from the xy, we just have x and then plus 6 is equal to 5. And to get y by itself, all we do here is divide by x plus 6. So now we get y is equal to f over x. Y is equal to 5 over x plus 6. And now all we do is just rewrite it. So we got f inverse of x is equal to 5 over x plus 6. However, we have to note what our restriction is to the domain, or what x cannot be. So in this case, x cannot be -6, because then it will become undefined. Therefore, this here is our final answer, and example number 3 is complete.